Yeah, thank you, and good afternoon, everyone. Welcome to the last session before our coffee break. My name is Maximilian Winkler, and I work for the German Federal Office for Information Security. And with me are Dominik Phillips and Tillmann Oßwald from ENW. And today we are going to talk a little bit about the telemetry in Windows 10 and some of the results we found out during our research. So how is this session going to be? We will start off by giving you a little bit of background, what was our starting point, where we are, or where we have been starting the analysis to make sure that we are all on the same page. And we are then walking you through the steps and the approach we take to derive the results and the analysis we did, and closing with some ideas and approaches when it comes to the question of how to tackle the issue with telemetry, whether you want to use it or not, or to what extent in your organization. So let's come to a short background. The analysis we did was part of a bigger project called Sisyphus Win10, which ENW conducts on behalf of the BSI. And within this project, we try to have a closer look at several security-critical functionality in Windows 10, like the TPM usage, the device guard, PowerShell, the application compatibility infrastructure, driver management, to name just a few, and of course, telemetry. And focus on this problem in this project was not to finding implementation vulnerabilities, but to get a general understanding of the architecture and the functionality of these components, because as this is operating system internal functionality, there's not much comprehensive public documentation available. So when it comes to the telemetry, we had a lot of work packages circling around this specific topic, starting with the original architectural overview we did back in 2018, following with a delta analysis to work out the differences between different versions of Windows 10, up to analyzing the underlying event infrastructure in Windows, and up to a data analysis and ways to completely disable this component. So what you see on this slide is a very simplified picture of how the Windows telemetry component looks like and how the architecture plays out. And this is what we presented at Troopers 2018. Basically, the telemetry service consists of two main components, and on the one hand we have that diagnostics tracking service, which is called enhanced connected user experience and telemetry service, which is implemented in a library called diagtrack.dll. This is the core telemetry service, and this telemetry service has access to two different kinds of data sources, which we call a primary data source and a secondary data source, whereas the primary data source is the event tracing for Windows infrastructure, or in short, ETW. And the secondary data source are executables and API functions, which this service is able to call and to execute upon special requests by the backend. And communication with the backend takes place via the network. There is the telemetry information pushed over to Microsoft Diagnostic Data Management Services, and configuration updates fetched from that network. So this was the state of our research back in 2018. But one blind spot remained, and we asked ourselves a question. So what about that data being actually transmitted between the client and the backend? How does it look like? What's inside? And how can we, it was basically the the founding question, how can we, with little effort, monitor and observe what is going on the wire or what is being sent out to the back end? And the question which came up was where to place that observation point to really have a look into what's going on. And the network interface of the telemetry service looks like it's displayed on the slide. It takes place via HTTP and compressed messages, encrypted inside a TLS tunnel with certificate pinning of the backend. So going after the network side would have meant rather more effort. So the decision was to just do it the same way as the telemetry does observe what is happening on the local system. And so the decision was we just also use the event tracing for Windows infrastructure to monitor the telemetry service. So, and how this worked out, having this said, I would hand over to Dominik.
So hi. As Max already pointed out, we are after the transmitted telemetry data, and I will talk a little bit about the preparation, how we get this data. As Max already said, there is a network interface, and in the end of the day, we want to see the data which is transmitted to Microsoft. And typically, what you will do in such a situation, you would use classic network analysis techniques or WinDBG, setting breakpoints, and so on and so forth. But as Max already said, we are looking for an approach which is a little bit more straightforward and supports us more during our data analysis, because we are talking about Windows telemetry and we are expecting a lot of data, and so we want to have an approach which supports us in the end during this analysis. So we decided to use what Microsoft used. As Max already said, we decided to use the ETW framework to collect the transmitted ETV data which the telemetry sends. For you who do not know what ETW is the tracing facility embedded in the Windows operating system, which enables you to track and trace activities in user land and kernel land components. From an operational perspective, the ETW tracing facility consists of three main components: the providers, the controllers, and the collectors. Providers are basically the ones who writes telemetry data. Collectors are the entities which collects or which receives the written telemetry data or the written ETW events, and the controllers are used to control and operate the ETW tracing, for example, starting and stopping or attaching specific providers to an trace session. So, what are the pros and cons of this approach? On the one hand, we have a well-designed architecture. We have a well-designed ETW tracing architecture which we can use. We have it's quite fast. We have reliable data sets. It integrates well with third-party tools, and so on and so forth. On the other hand, we have the ETW providers or the measure points, which are somehow problematic, especially when you are not the one who developed the measure point. Because imagine when you do not are the person who developed the measure point, you do not know what data will be sent by this measure point. You do not know how the layout of the data is, and so on and so forth. You need to figure this out by yourself during your analysis, and this is a downside when you want to use this technology. So the challenges are we want to utilize the advantages. This means we want to set up an environment which we in the end can use and utilize the advantages, especially when we want to handle huge data sets. And there's ETW which supports us quite well, so that's already a good point. But still, we need to build up an analysis environment. And on the other hand, we have the challenge regarding the providers or the data which we are after, which we in the end can use to to fulfill our mission, and in the end, collecting the data which will be sent to Microsoft, which means we need to identify measure points, we need to identify records which reflects the action, the sending of the data, and we need to ensure that these actions are really linked to the specific action which we are after. So how can we discover ETW providers? There are different tools which you can use to discover ETW providers, all developed by Microsoft. What these tools do, they discover ETW providers based on basically in two ways, either on information which is stored on the system or information which is provided during runtime by the ETW environment. So if a provider registers itself during runtime against the ETW environment, telling the ETW environment, hey, I'm here, I'm ready to send data. That's the information which these tools get via this approach. The problem here is what you get is only you have an UID and you have the name, but there's some quite important information missing, at least from our point. There's information missing where the provider is implemented. So we have just the name, but we do not have the link to the actual implementation or to the binary where the provider is implemented, which is relevant and for us, because when we have a scoped scenario, in this case we already have a scoped scenario where we have a process. This process consists of different binaries and so on and so forth. So we want to know specifically for specific binaries, are there ETW capabilities embedded? Then we need another approach to do that, because the normal tools won't give us this information. They just give us the name and that's it. For installed providers, as said, they store information on the system. They store the information on the file system or in the registry. So for installed providers, we can get this information from the registry, but everything which is registered during runtime or is loaded dynamically somehow, there is no way to link a provider to an actual implementation or to a binary. This is why we prefer another approach. We prefer a scanning approach where we search in each binary for metadata artifacts, which a binary must include if it hosts ETW capabilities. And that's our approach. That is what we do, which gives us the advantage that we are not relying on install, runtime, or whatever information, so we search for these metadata artifacts. The downside, of course, is you need extensive knowledge how an ETW provider is implemented in a binary, and even there are different ETW providers, so it's not that you just need to know how one ETW provider implementation looks like. You need to know it for every different type of ETW provider. For example, there are WWEF providers which store this information in the resource section, and in this case, or what this figure shows, is a TLG provider which stores this information in the read-only section starting at a specific offset, which can be identified by a specific pattern, by a specific header with magic keys and so on and so forth in there, followed by event blobs, which in the end describe how an event look like and what metadata are in this event and how the layout looks like. There are different tools which you can use to identify binaries which have this metadata embedded. There's one tool which was developed during the project, and there's also another tool developed by Matt Graber. The tool developed in the project covers more providers than the tool from Matt Graber. This tool just covers TLG type providers, and the tool developed in the project covers different types and more types of ETW providers. So if we use this approach and scan the diagnostic tracking service DLL, we can see that there are, or we can figure out that there are 11 providers in there providing us or covering over 1,000 different records. So the binary is heavily distributed with tracing capabilities, which we can use or which we want to use in analysis scenarios. As said, these providers not just search for these patterns, these tools also can extract the metadata so that we have a better idea how the layout and how the capabilities of these providers might look like. In this case, you can see on the right side the layout of a specific record, where we can see the name of the record, some technical information of the record. We can see the names of the fields, what the data types the fields have, and so on and so forth. But still, at this point, we're still on a metadata level, so we have information about the layout, but we do not have concrete data. So if we look at the field, the event payload field, we know, okay, it might be a string in there because we have the data type, but we do not know what this string might give us or how this string really looks like. So in order to get this information, there is no way. We need to run tests, do static or dynamic analysis in order to get this information. If we do it for the Asimov upload persist event record, we can see that in this case the event payload field contains a string, and if you're familiar a little bit with ETW data sets, you can quite easily figure out that this is an ETW data set formatted as a JSON string. In this case, we are talking about a TLG provider event. TLG provider events also always go by name and not by event ID, so they have names. And typically what the developer does, they follow some sort of naming convention, and in this case also we can use all this information, this metadata information, together with now the concrete data to figure out if this is something which might helps us during our analysis. Is this the information which we want to see, or is this the information which might be transmitted to the Microsoft backend? The record name, Asimov upload persist event. Asimov is the code name for telemetry data in the Microsoft world. Upload persist event, I think, speaks for itself. Still, at this point, we are not 100% sure that this is really the stuff which will be uploaded, but we already have some indicators which you can use. In order to be 100% sure that this is really what the scenario, what we are after and what it reflects, we need to analyze, do a static and dynamic analysis. Otherwise, there is no way. As said, we have metadata and we have the data when we did some tests. But to really be sure that this is really reflecting what we are after, we need to have a look at the binary. There is no way around it. There are simple scenarios, as in this example, where you have, for example, in function, you have a specific action, you have afterwards the write operation, and it's quite easy to figure out, okay, just by looking at it, to figure out, okay, the write operation is directly linked with a specific action. In this case, it's about enabling providers. Afterwards, you directly have the write operation, which tells us, okay, which providers was enabled, and that's a quite simple scenario to ensure that a write operation is linked to a specific action. In the context of the Asimov upload persist event provider, that's a little bit different because the write operation is done quite early, and in the end of the day, we want to ensure that we are after the transmitted data. So in this case, we need to evaluate the whole chain, beginning from when a telemetry event arrives at the diagnostic tracking service, when it is converted to JSON. Afterwards, there is the write operation with this TLG provider. Stuff is compressed, is loaded into a database. From there on, the data is read and then sent to the Microsoft backend. So to ensure that this trace event is really reflecting what we are after the sent data. We need to evaluate the whole chain. In this case, this takes more time as the example before, but this is something which always depends on the situation, on the specific implementation. In this case, we are lucky, and as said, this event reflects in the end of the day the sent data, and we can use ETW and we can use the tracing capabilities to, in the end of the day, collect and have a look at the sent data to Microsoft.
Okay, thanks, Dominik. Now we have our provider identified, and we can start thinking of our analysis infrastructure. That's what I'll discuss in the next few slides. And then I'll discuss how we performed the analysis of the data. So first, a little disclaimer. We used two systems to perform the analysis on, Windows 10 and Windows 11 host. They were running in a virtual machine, but we tried to use them as normal as possible, I would say. So we tried to do our daily work on them, browsing, development, clicking the PowerPoint slides and so on, locking the screen. But in the end, we also used our host machine for some tasks potentially. So there might be not all the interesting data in there. For example, I did not use any email in the virtual machine, but on my host system. So yep, that points to a direction what data is in there, but potentially there could be more data. Now, to the data analysis setup. We have now the provider that Dominik discussed, and we can collect data from there. But as we can see, it's a large amount of data. So over 1 week, we have accumulated 300,000 events from that particular provider. From these events, 8,000 were related to the transmitted telemetry data. That's the actual event and what we're interested in. And we had a peak of up to 800 events per minute for this record. And so from this, we have a set of requirements that we want to achieve with our analysis infrastructure. So our solution must be performant on two sides. On one side, on the recording side, and on the other side, on the analysis side. And we want a possibility to filter and search for data, again, on the collection and also on the backend side. And we want quite a flexible data model. As we already saw a record, it has a lot of fields, and we want to search in the fields, and we don't know what telemetry data is transmitted, so we need to have a flexible model. And what's also important for us is that we have a flexible approach that is transferable to other research questions. Because in the end, we are not only interested in telemetry data, but there are other questions that are important to us as well, and we want to reuse our infrastructure. So capture analysis should be decoupled as possible, and using other capturing and analysis backends should work as well. With that in mind, we came up with a solution that uses the ELK infrastructure as the backend. So starting from the left, that's our Windows 10 and 11 systems, where telemetry was set to optional, is the word from Microsoft here. That's the highest level of telemetry data to send, because we wanted to see what the biggest impact could have been. Now we need a solution for starting and stopping a ETW tracing session to record the events we're interested in. For that, we used SAM, System Activity Monitor. That's a tool that was developed in the course of the project. There are some other tools like Xperf, Windows Performance Analyzer, but from our view, they had some downsides, so we used SAM. What's nice there is it enriches the records with further metadata. Also, it allows filtering during collection of the events, and it fits the performance requirements. And it logs into the Windows event log, so it's pretty pluggable in the end. Then we forward these events to another system in the middle that is only responsible for gathering events, sending them with WinLog beat to the ELK systems in the backend. And on the ELK systems, we have the Elastic servers where the records are indexed, and we have Logstash for further processing, and Kibana to perform searches there then. Now let's look at some telemetry data that we can see what's in a typical record. So a record consists on a conceptual level of at least 3 types. It has a header that is visible at the top. It has an extension field and a data field. The header is always the same. It includes a version that can vary. For example, if you look at the analysis package, the version is 3. Now we skip to version 4. Here we have the name of the ETW provider that produced the event. In this case, Microsoft Windows, Bluetooth, VCH port, local driver information. That already gives the first information what the telemetry data could be about, and we have a timestamp when the record that is now used in the context of telemetry was generated. So the extensions field can depend varying on the telemetry data that is sent, but what is always present are the following fields. It's operation OS. That's version information, a boot identifier, so it increments during boots, a device class, for example, desktop and desktop machines, a device GUID, an app identifier, that is the application from where the telemetry record was generated initially, and a user GUID. Now, to the data field, this field is always specific to the record that produced the telemetry. In this case, if we remember back, it was related to Bluetooth and device information, and what we can see here is plenty of information regarding a Bluetooth driver. So we see the corresponding inf file, OEM4.inf at the bottom, the driver provider Intel Corporation, we have manufacturing information, a description of the driver, we see it's a wireless Bluetooth driver, device instance IDs, installation time of the driver, so we already see there's a lot of information included in there. In the next set of slides, we mostly focus on the data field because that's the most interesting from our point of view for individual records. So we categorized these types of data that is transmitted to 2 plus aggregated data. So what we saw now was, from our point of view, technical data. That's data that Microsoft has and can conclude something about the machine, the operating system, that could be like the Bluetooth event, it could also be settings that are set on the system that are sent over. On the other hand, we have activity data. This is if the user does something, telemetry data is generated because of the action and that is transmitted. And also we have aggregated data if we use records for and combine different records to aggregate the data and get new insight. What should be said here is like we made a pre-selection of records that are easy to present because you do not need that much knowledge and that are easy to understand because, for example, on some events we had base 64 strings, we decoded them, it was binary, and that would have took more effort for reverse engineering to really figure out what that data would have been. Other events, for example, pertaining to Windows Update, we could have done another talk before that to discuss how Windows Update works. So there's only some showcases to show what's happening there. So the first event I want to point out is a traceroute information event. And we can see that already it's not the full traceroute that is sent. That's interesting. We only omitted some hops in the middle, but it only starts at hop 3. Then hop 6 is included, and 7, 8, 9, 10 was included, I guess. So some hops are omitted, but still we can conclude some information. We know that system is running inside of an ERNW network. We get information about Filescom, our service provider there. So that's technical information that is sent via telemetry. Another example for technical data is events from Windows Defender. We can see Windows Defender identified mimikatz.exe on the file and sent a report via telemetry to Microsoft. Now, that's interesting and Microsoft gains insight, but what about user activity and user tracking and user behavior? So this is an event from Edge, and we can see the page title that is used. Sisyphus A-Funkt search. Well, that looks like someone did a Bing search maybe. Now let's look at the next event. What can we gather from here? Oh, that's a navigation event. So we went from the referrer URL, bing.com, to the navigation URL. Oh, that person was really interested in our research and went to the BSI homepage to the A-Funkt work package. Now, what's happening on that web page? Well, the person clicked a link. Here, that one. The person downloaded the PDF. And guess what? What happens when you downloaded the PDF? Well, you open it. And here's the path. So as we can see, there are quite a lot of information included in these events, but it's only a showcase of events that are easy to illustrate and we figured out right away. Now let's take a look at some aggregated data examples. Here we can see the number of events that have been generated per application in logarithmic scale. That's just an example. There are a lot of applications running and producing events. We can also make some conclusions what's happening there. For example, we see that Edge was used, Logon UI was used. We also know PowerPoint was used, or code was used. So that gives a first insight into how a system is used, or for what purpose a system is used, what kind of machine it is, and so on. If we take a look at a linear scale, we quickly find out what activity Microsoft is interested in. We can see they are really interested in their services hosted in svc host.exe, and also Edge browsers, really interesting for them. I think that's a point where we can see that they try to improve on their Edge browser and really need a lot of telemetry for that and get that telemetry over that way. So let's take a look at another example of aggregated data. Here we have a graph of telemetry records over time. So the blue line, on the bottom axis we have the time of day, on the top we have the count, and the blue line indicates how many records were generated per 15 minutes. It's rounded to 15 minutes. That was a Thursday 2 weeks ago, I guess. So, okay, that looks interesting. We might draw some conclusions, but hey, we have some more information there. What about user logins? So Logon UI produces an event in case a user logs in. So let's take that into account as well. And hey, we have Edge data, let's use it. So now we have a clearer view. The red lines are now the logins, the time the login was performed. The green dashed lines are the amount of Microsoft Edge events, and the blue lines, the total number of records. So I'm a bit afraid my boss is in the audience, so it was a Thursday. I started at 10:30. Please remember that there was team meeting and it took really long. So I started earlier, yeah, but I was on the phone during the call. So yes, I started the machine at 10:30, that's true, and then I did some work in the browser. During boot, often most events are generated. Yeah. Then some browsing. Then potentially I grabbed a cup of tea for the first break. And then at 12, well, you know how it goes. You got hungry. You grabbed some food. At around 1, I logged in again after I unlocked my screen. And then the afternoon was mostly browsing. And there I did some development work. And Visual Studio does not produce that many events, so it looks like I didn't do anything, but I was really active, to tell you. So from that we can see that Microsoft gains a lot of insight from telemetry that is not from one record, but from multiple records. And this is just a showcase. Here the creativity is the limit. I just included like the amount of Edge events and the time of the login. There are also events related to power, so you can include when is the machine turned on, turned off. We discussed traceroute information. Maybe we can figure out when a user is moving from where to where. And there are plenty more of events. So in the end, there's a lot of information in there. There might be more if you get creative. So now we know that there's a lot of information. We want to take a decision, and I'll hand over to Max.
Thank you. As you have seen, the data being transmitted via telemetry is able to draw a very precise picture of what is going on the local system. And what we just presented here is only a part of the telemetry data collected throughout the test run. There's way more, often not so easy readable because it's binary data or bit fields, something like that, but way more. But in the end, we think it's not, that the question is not about what data is being transmitted, or maybe at least not solely what data is being transmitted, but it is more about taking an informed decision and being able to justify that decision in which direction you go, whether to use telemetry or try to deactivate it. And we think one approach to tackle this could be by defining some key questions you really need to answer, or which are interesting for your organization to find out in order to decide about telemetry. Answer those questions and weight the answers in the pro and in the con bucket against each other, like you would do in risk management processes, comparing risks against opportunities. And then take your decision, whatever comes out, and justify. Because telemetry nowadays, that's not just black and white or 0 or 1, because sometimes telemetry just could be required. For example, or maybe one example which is on the slide is the smart app control, which is a feature in Windows which requires telemetry to be activated. And usually there is at least some configuration possible with regard to telemetry, for example, to deactivate only browser events and go with the rest. But in all these cases, it might be really helpful to looking into the data to get a better feeling of what is being transmitted. And so this is, at this situation, the tool we developed, SAM, could really be helpful. And coming back to what I said before, the key questions, some key questions which might be helpful to come to that decision are displayed on this slide. So, for example, it could be, do we have a special trust relationship with the vendors, Microsoft? Where does the data reside, which is being collected via telemetry? Are there any regulations in place which might push the company into one or the other direction? What about features? Is there a feature connected to telemetry which we really want to have, or which we are afraid to lose if we deactivate telemetry? Are there any special contracts? For example, you just lease your IT systems and it's not allowed to tackle with the configuration. Are there compliance rules in place in your organization? And what about confidentiality requirements or integrity requirements? And to answer those questions, put all those together, you will come to the final answer for you to help you with this decision. And to make things a little bit more, maybe more physical for you, this is just a matching between those key questions and the federal government use case for the federal client. So what about the trust relationship? Is there anything special? Well, Microsoft is a US-based vendor under US regulation, so there's no special trust relationship we have with them. Where does the data reside? Well, in this case, it resides usually outside Germany, depending on the data center of the backend. Are there regulations in place? The answer to this, is, which might affect most of you as well, is the GDPR, for example, the General Data Protection Regulation in the EU. So what about features? Are there features we really want to have? No, there are no features which we really wanted. The same applies to special contracts. There are no contracts in place which have ramifications or an effect on that decision. And I mean, now we come to the juicy stuff. What about confidentiality or integrity requirements? And those are very strict in the federal government as we process restricted information, and those information and even snippets of it must not leave the network, which cannot be guaranteed by using telemetry. And and with this, in this regard, also applies the compliance rules, for example, restricted information handling directives and similar things. Please keep in mind that this picture could be totally different in your organization. This is just the way which led to the federal government saying there's no telemetry going on. And well, we think the methodology we presented, or this approach with the key questions, can be applied to almost any product telemetry running under Windows. really, really important is to take informed decisions, and you will be fine and be able to justify these. And yeah, one thing I want to give you with you on the way is the tool we developed, SAM, is really great to look into the data, not only to detect what's going on with telemetry, but it is able to just look into everything what's going on inside the event tracing for Windows infrastructure. So it's also possible to detect other behavior inside the ETW infrastructure. So yeah, please use it. So with this being said, I think we are happy to answer any questions you might have. And thanks for your attention.
All right, thank you guys. Are there any questions from the audience?
Hi. Did you monitor how often Microsoft updates the telemetry during Windows updates?
No, I think we did observe this during the original analysis back in 2018. Do you have the exact numbers?
So it's the question how often the software is updated or how often configuration properties are updated?
When are new events introduced that Microsoft is getting? Do you monitor how, for example, the Edge events evolved?
So regarding if Microsoft can update measure points, so if they can extend the set of telemetry data, what they collect, they can do it. It's all dynamic. It's based on configuration files. And what we observed in 2018 was that the client at least one time a day checks if there is a configuration update.
Oh, yeah.
Hi. Did you try to get this data in a legal way, like asking the Bundesdatenschutzbeauftragter to ask Microsoft to get the documentation before you started to carve it out of the binaries and logs?
You mean the question was if we try to ask Microsoft to get all the details about the data structure and what data they do collect? No, what we wanted to do. So maybe it's a two-part answer. The first one is we really did want to have an independent analysis of Windows 10 in this project. So really independent from the manufacturer and not to rely on information from the manufacturer. And the second part answer to your question is that there is so much going on with the telemetry and data which is being collected, so I do have really doubts that there is that fixed list available at the vendor side.
Yeah, so also we are in a quite close communication with Microsoft, so we discuss stuff with them, and when I remember correct from the last meeting at Microsoft, the person which is responsible for such questions, of course we discussed such things with them, and what I can say, when you ask them question in this direction, this person was quite nervous. I would describe it in that way. So, yeah.
Are there any further questions? Okay, so let's thank the speakers again.
Okay.